In this video, I'll be covering question 1, part D from the 2023 AP Calculus AB Free Response Calculator Required portion of the exam. I cover parts A, B, C, and D all in their own individual videos, so if you want to see the solutions to A, B, or C, please check out my other videos. Okay, so diving into D. D is saying using the model G defined in part C, so that's going to be this equation right here. They want us to find the value of G prime of 140. And after we find that value, they want us to interpret the meaning of our answer in the context of this problem. So the first part of this is going to be pretty straightforward, finding that derivative value, especially since this is a calculator required portion of the exam. We can do all that in our calculator. We don't have to find the derivative at all ourselves. What you would want to do, step one of this process, is in y1, you'll put that original equation. Everywhere I see a t, I would put an x in here. Whenever you're graphing, remember your calculator doesn't like anything but x's when it's graphing. So we put all of that into y1. Step 2 now is you're going to want to graph this equation. A couple of things when you're graphing. First and foremost, remember the entire AP test is really in radian mode. So make sure your calculator is set to that radian mode. It's the default setting on your calculator. So unless you adjusted it, it should be there. Then the next thing you have to be careful of when you're doing this type of problem is your x window always needs to be large enough to take that value in. So our x value on this is 140. So I would want to go to my window and just make sure my x max is out to something bigger than 140. I'm going to put mine to 150 because that's where it was set from the last problem. Yours should probably still be set there too if you did part C right before part D here. Now step 3 of the process, once we graph it, we hit second. We choose the calc menu, which is the button above trace at the very top of the calculator. And then inside that menu, we'll choose the number 6 option, dy dx. We'll hit enter on that. That'll push us back onto the graph. And once we're on the graph, we're going to need to type in the x value that we care about here. The calculator won't prompt you to do that. You just need to know that that's the way this process works. We'll type in 140, hit enter, and then at the bottom of the screen, we're going to get dy dx equals, and whatever that is going to be our answer. Opening up our calculator, go into the y equals. If you did part C before this, you would have had 1 over 500 or 1 over 150, put in there from that average value formula. You can just hit this delete button up at the top right next to the mode button. I'll use it just to delete that parenthesis off for you so you can see it in red there. You can delete everything off, and now I'm going to insert that parenthesis back, and you not have to retype the whole thing. And that's one of the reasons I like graphing a lot of this stuff is very often you can reuse the equation you already had in there. Now that we've got the equation in there, we'll hit graph. And again, my window, I've got it set. I hit window up at the top. I've got it set out to an x max of 150 already from the previous problem, and I'm already in radian mode as well. We've got all that in there. We hit our graph. We don't really need to see much more than that. We just need our x window to be large enough to take in the x value we care about. I now hit second, choose the calc menu, which is the button above trace at the very top. And then inside that menu, I'm going to choose the number 6 option, which is dy dx. I hit enter on that. It puts me back out onto the graph. And again, it doesn't prompt us to enter the x value we care about. We just need to know that that's the way the process works. I type in 140. I hit enter, and at the bottom of the screen, I can see dy dx equals negative 0.004909. On the AP Calc test, they generally want everything on the final answers rounded to 3 decimals. That's the accuracy they're looking for. So on this one, we'd be looking at negative 0.005. Now let's use that answer and kind of put this all back together in terms of the problem here. We need to now interpret what is the meaning of this. So we have G prime of 140 equals what we just got out from up above, negative 0.005. When I want to interpret the derivative side of this over here, when I want to interpret what that number means, the units on that are going to come from this type of notation here. dy dx is how you want to think about it. It makes it the most useful. You can track things in dy dx's. You're used to things in y and x terms. Then what I do is I change it into the language of the problem by changing out my variables. So instead of y on top, the y value is my g value. That means this is dg and the x value is my t value, dg dt. Now I come back and go back and find those units, because what we're looking at is the change in g units over the change in t units. And that's going to give me the units on my derivative right here. My g units were in gallons per second, the rate of flow in gallons per second. So my top units are gallons per second. And then the t units were given to us back up in the language of the problem. That's just going to be seconds. This is one of those situations where having this type of setup in place where you know how to put together your units is super helpful, because sometimes the units don't make the most sense, but that is what we're talking about. So this is gallons per second per second. That's what these units are here. Gallons per second per second. Now when we come to interpret this, you just kind of work your way left to right through it. And you say, at time t equals 140 seconds, whatever your x value is, whatever the x piece is going to be what you start with here. So at that x value piece, the rate of change, because we've taken a derivative, so we're talking about a rate of change of, and then whatever the y value is, the rate of change of the rate of flow of gasoline. Again, sometimes these things you just have to have a process and you just plug the pieces in, because it doesn't always make the most sense, in terms of real world stuff in the head always. Rate of flow of gasoline is, now you're going to enter in the term increasing or decreasing. So if your derivative is positive, it would be increasing. If your derivative is negative, it's decreasing. So the rate of flow of gasoline is decreasing at a rate of 0.005 gallons per second per second. And again, so how I look at this is I say, usually it's a time, t equals whatever that value is there, and make sure you put the units in. The rate of change, always use that, that's what you're finding with the derivative. You're finding a rate of change. And then whatever your y value data is, the rate of flow of gasoline, and you just go find it. You copy and paste it really, is, and then we always want to use increasing or decreasing depending upon if our derivative is positive or negative, at a rate of, and then you just put in your answer that you get from your derivative and put your units together using your method here. So that's how you handle part D. Part D would have been worth 1 point for finding out just this piece of the answer, and you would have gotten 1 point for putting it all together for interpreting the meaning. Thanks for watching my video. If you liked it, please click that like button and subscribe, and also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.